All right, everybody, we're back. It's Brett again. So today we're going to talk about Chapter 6, which is all about attribute data. So we've been looking at the tables. Chapter 5 is more about making pretty maps, but today we're going to actually get kind of into the nitty-gritty of what you could do with the data. There's some techniques utilizing the fact that the data is actually a relational database as opposed to just a flat table, like let's say an Excel spreadsheet. So we're going to utilize that power to start to be able to combine data sets where you didn't think you'd possibly be able to do it. So some of the things we're going to look at is go over again, briefly review what is a table. There's a lot of stuff going on in a table. You've already seen tables. Asking the data a question, so a query. What can we ask? How do we ask the data a question using SQL? Joining and relating tables, which is the newest concept for this particular chapter. And it's one of the hardest concepts to kind of wrap your head around. And without being able to do GIS, it's going to be even that much more difficult to understand. I will do my best to explain that. Then we have summary statistics, which is, again, another little handy technique that you can use to get some quick and dirty statistics based on groups of data. We'll briefly discuss storage concepts for databases, and then kind of looking at how you do this stuff actually within the confines of the program itself. All right, so let's go back and look at what is a table. So if you remember, hopefully you remember, a table, kind of looks like an Excel spreadsheet, right? You have columns and rows. The columns are called fields. They're also called attributes. And the rows are called records. And you can have a lot of rows and columns. I mean, within a geodatabase, there's almost no limit now to the number of columns and rows. You can have millions of rows and I think several thousand columns if you needed it. Each field, what we'll find as we work through this, each field has to be explicitly defined before you can actually create it. And I'll explain more of that as we go. It just has to do with, it's a little bit different than Excel, where Excel will let you just start typing in data. Whereas in a GIS, you have to define what kind of data is going to go in that particular column before you can do it. So there's two kinds of data, and up until this point, we've been dealing with mainly just one. The one on the left is the attribute table. It stores attributes of map features associated with the spatial data layer and has specific spatial information in it. So things like the shape field here. The shape field is intrinsic in GIS. It's created for you. You don't have to mess with it. It's always there. And it automatically tells you what geometry you're dealing with. Along with this, some type of ID field that's automatically generated for you. So we've been dealing with this attribute data since the beginning of the semester. There's also another type of table called what's called a standalone table. Now this is just a table of data with no attributes associated with it. There's no points, lines, or polygons. It's just data. Okay, and it says here there's an OID, which is this OID instead of an FID. Now, just because it doesn't have points, lines, or polygons associated doesn't necessarily mean that you can't use it. There are ways of combining data sets, which we'll talk about again with the joins and relates. So not all is lost depending on how the data is set up. So how do we ask questions? Now, chapter 8 is all about queries. It's a little bit more detailed in terms of what we're going to talk about. There's even more questions, but we've already talked about this a little bit. In fact, I think we've been doing some queries since chapter 2. It basically, you're extracting certain records from a table based on a specified condition. So you ask the data a question and you get back an answer. This is an absolute essential part of doing GIS. You never want to carry around more data than you have to. If I have all 50 states and I only need Wisconsin, I'm going to ask the data, give me the state that equals Wisconsin, and I'm going to kind of toss the rest out. And that's how you do this. This is how you start to learn how to ask questions to get into the nitty gritty of the analysis you're trying to do. Okay, if you're doing some type of study where you need states, that have larger populations, well, 1 million people is a pretty good cutoff. So here you can ask population greater than 1 million. Excuse my really horrible circles there. You can ask, you can compare data. How many counties had greater population in 1990 than 2000? So you're comparing two different dates. And the bottom one is used quite a bit, where you can actually do what's called pattern matching, where you're looking for specific um, patterns in the text itself to give you to whittle down data. Um, uh, Address location does a lot of this type of stuff. Give me all the streets or all the avenues or things like that. So how do we ask the questions? The questions are asked with a programming language called SQL, which stands for Structured Query Language. Now, Structured Query Language has been around forever. I've been using SQL since 1999. It's used in almost all database environments. Not all. There are some that are what they call SQL less, but most major relational database management systems, DBMSs here, um, they all use SQL. So if you know how to write SQL GIS, it's the same kind of SQL you would write in Oracle, some higher level, huge database network. You can save queries and reuse them. That's important when you have really complicated ones that you don't want to have to keep retyping. And it says nearly here. Just ignore that. Okay, we're gonna scratch that out. Just assume they're always case sensitive. Always. So a capital F is not the same as a lowercase f. So if you're looking for states, you should probably capitalize. If I want all the states with the letter M that start with the letter M, I'm going to capitalize that letter M. So here's some examples, and I think we've seen this slide a couple times, and we've already done the select by attributes before. Here you have all of your columns. These are all of the headers in your database, in your attribute table, excuse me. And then you double click in here. What you don't want to do is you don't want to type in here anything. You want to type this at all if you don't have to. However, numbers you do have to type. There's nothing you can do about that one. So what I would do is double click population 2010 right here. Double click that, it pops down there. Then click once, the greater than sign, it goes down there, and then manually type in whatever number I'm trying to compare to. You never want to type in here if you don't have to. Any tiny little what do you call it? Grammatical error, so to speak, is going to um, generate an error. I mean, it just won't run. SQL is very specific. So here's some valid queries. Now you'll notice that the actual query starts with the word select. Okay, I'm gonna erase some of this stuff here. The actual query is right here. So this is the whole thing. Select star, I'm going to jump up here, select star from cities. So what that is telling you is it's going to select star means everything. Select everything from this attribute table where, and then my criteria here, my condition. Now in real SQL, you have to write out this whole thing. The beauty of GIS is the fact that all you really have to do is you only have to supply the where clause, which is what's in the box here, the population greater than 5 million or 500,000, excuse me. So you can see here that the actual select star from counties where is all written out for you. So you only have to write out what's in the box. However, if I was going to test you on this, I would require that you have to write this entire thing out. Whoops, my circles are horrible. You would have to write that entire thing out because you can't have just writing the population 1990 greater than 500,000 is not correct. You have to have the whole thing in order to make it a valid query. So on tests, you have to write this entire thing, the whole thing, not just this part. Give me just this part doesn't mean anything because I don't even know what table it's coming from, which is cities. So each one of these is a valid query, even though in the program you only have to supply what's called the where clause. So that's kind of nice. It makes it easy to learn. Okay. So, and here's some other examples. You have select star from counties. So counties is where these columns are located, where beef cow 92 is less than beef cow 87. So apparently, beef cow 87 was a pretty good year. You can also double up criteria. Select everything from parcels. Now, parcels, if you don't know, parcels are the footprints of buildings. Okay, so when they do tax assessing and stuff like that, any house you live in has a parcel footprint. Give me the land use code where it equals 42 and a value of greater than 50,000. So you have a double criteria here. When you add these multiple criteria like this, which we'll talk about in a bit, you're even further making it a more specific question. You're restricting it even more. You're going to get back way less from a question like this because it's very specific in nature. And you know what? That's a good thing. Because again, when you're doing GIS, what you want to do is whittle down the data to just what you need. So here's another example, select star from rentals where the rent is greater than 700 and less than 1500. This is a basic inequality just like you did back in grade school. You want everything in between 700 and 1500 per month. Okay, so there's lots of different ways you can do this, and it takes a little bit of practice. Unfortunately, we don't have that option right now, but it takes a little bit of practice. So, getting back to the multiple criterias, this is exactly what you want, where you want to kind of take your analysis. What I call this with my students is pre-processing. So when you go to download a data set, you probably have way more data than you need. So right away, you have to start to whittle it down to just what fits your analysis. So you have things like, give me state equals Alabama or state equals Texas. Okay. Now, you have to notice, if you look at this condition down here, you have to do it twice. I have to write both of these out, not just state equals Alabama or Texas. It has to be state equals Alabama, the word or, which is a button in the attribute table thing, state equals Texas. If I get rid of this state equals over here, it's an error. And over here we have value is greater than 5,000 and value is less than 10,000. All right, we'll get into and or in a second here, but just for multiple criteria, just remember you have to have the criteria both times, both conditions. You can also do partial pattern matching, which is really helpful with a lot of things. You'd be surprised how often you're going to want to use this. The thing is just it takes some practice because of the syntax of the SQL. So you could do things like find all customers' names that begin with MAC or MC, McDonald. Find all the zip codes beginning with 0. Now, zip codes are technically numbers, but it's actually nominal data. If you remember from chapter 4, it's nominal data because you can't add or subtract them. They're just unique identifiers. So a lot of the little East Coast states, like New Jersey, for example, their zip codes begin with 0. All right. So here's how you do this. You use what's called the like operator. Now, again, this takes a little bit of practice, but it's hugely helpful for finding specific types of data within a large data set. So if you look at the data over here on the right, you'll notice that each one of these has a parenthesis and then their political affiliation. Some are parenthesis D parenthesis, and some are parenthesis R parenthesis. All right. So if we want to find all the Democrats, we can use the fact that each one of these has a parenthesis, then a letter, and another parenthesis. That's a pattern. It's a pattern found in all of them. All right. So we're going to key in on finding all the Democrats. So we're going to use the fact that the parenthesis D parenthesis is either found or isn't found in all of them. So to do that, we use what's called the like operator. Excuse me, the like operator here. So the name the name is the name of the actual column right here. Here's the name. So that name, I double click name, I click the like operator. Now this part here is what takes practice. You actually have to type that in there. There's no other way to do it. You'll notice there's a single quote, a single quote here, then a percent sign, then the pattern we're looking for, another percent sign, and another single quote. It has to be done exactly like that. So what this does is because of the fact that we have a very specific pattern in here, it looks for all three of these or it fails. So it looks for the parenthesis, the D, and the parenthesis in this pattern here. Otherwise, it will fail without question. All right. So it will ignore things like Don or Danforth because they don't have the parentheses in there. All right. I'm just erasing some of this stuff. All right. So here's another example. You can use an actual space, like hitting the space bar. So here you have name, like, and here we have the single quote, the percent sign, the word new. Now right here, this is a space. That's like I'm hitting the space bar. Okay, and then the closing percent sign and the closing single quote. That space can be searched for just like it was a letter. So it would find things like New space Hampshire. See, there's a space in here right here. There's a space there and there's a space here in New York, but there's no space in Newcastle and there's no space and this is not capitalized. So it would not find either one of these. It would only find New Hampshire and New York. So you can be very specific about how you're searching for your data. Again, this takes some practice, but it's hugely helpful when you're trying to whittle out specific types of data. For example, several times I've used the river attributes, the big rivers for the entire state of Wisconsin. And there's so many little tiny rivers I don't need. So what I do is I use the name field and key in on the actual word river. So if it has the word river in it, those are the more common rivers, things like the Wisconsin River, the Milwaukee River, the Menominee River. So it basically gives me all of the major rivers just by searching for the word river within the name. So once we do a selection, what do we do with it? And this is, again, a huge part of GIS, especially sort of in the beginning stages of analysis. Once you have the question, you wrote the question correctly, and you get back an answer, you're going to get that light blue color on your screen. That light blue color tells you, hey, something is selected. What can I do with it now? Now, this here, okay, this right here is a cardinal rule of GIS. Okay, once you have something selected, any operations that you do on that table will only use the selected records. That's a good thing and it's a bad thing. It's a good thing if you needed to do that, but it's a bad thing if you forget that those things are selected. Okay. So once they're selected, you have to remember that anything you do, whether it's statistics or anything else, any tool you might run is only going to be run on that particular subset that is highlighted in that blue. So this is one of those cardinal rules of GIS I try to tell my students. Along with, if you go back to chapter 3, with the coordinate systems, with the first data being added to a data frame. So this is a big thing. And sometimes I forget to, I'll run a tool not knowing that there's one tiny little polygon somewhere on my map that's highlighted. And I just ran the tool on that tiny little polygon that's highlighted. All right, so now that I have that light blue color on my screen, what can I do with it? Well, I can export the selected records to a new table. That's typically what I do. All right, that's the first thing I do. I'm a bit different this way. I like to have separate data sets for everything I do. It's one of the reasons I don't create a lot of layer files. Layer files require you to carry around all of the original data with you, and I don't want to do that. I want just the data I need for my specific analysis. So I will do a query of some sort. All right, and there's different kinds of queries. I will do a query, and then I will take that and export it into a new table. So I'm isolating it, I'm taking it out, and then just discarding what I don't need because I don't want to carry around everything I don't need. You can also calculate statistics on these new records. Again, that goes back to this rule up here. Once I have something highlighted, any statistics I do are only going to be for the highlighted records, which is great because that's what you. Let's say I highlight all of the states with the letter that start with the letter M. I always use that as an example. Then if I go into the attribute table and I right click on, let's say, population 2000, any statistics if I go to the statistics, it's only going to give me the statistics for those states that begin with the letter M, as long as they're highlighted on my screen. And that's really nice. If I just need a quick, maximum population, total population for all the states that begin with the letter M, that's a quick way to do it. You could also calculate new values for the selected records, which means you could add a field and do a calculation or produce a report, which we don't ever do in my classes. But knowing that most of the time you're going to export things or calculate quick statistics is hugely helpful in GIS. Okay, so joining and relating tables is one of the weirdest concepts I have to try to explain in this course, and it's hard enough in class, so I'm going to try to do this as best as I can over the webcam here. Now, sometimes you have two tables that you want to map. The problem is the data that you want on your map is in one table, and it may or may not have any type of spatial geometry with it. So if you look at my table over here on the right, this table, the source table, that table has no points or polygons. There's nothing in there that says polygons, polylines, or points. So how am I able to use that then? Well, there's two methods of being able to do this. But you have to set up the problem first, so to speak. Now, if you look at this diagram, you'll see it says destination table on the left and source table on the right. Now, the first thing we have to do is figure out, okay, I want to figure out how I can kind of sort of combine these two tables together. So I open up the attribute tables and see if there's a column in each table that is the same. In this case, this one has FIPS and this one has FIPS. Well, that's convenient, because a FIPS is a federal identification number, think of it sort of like a social security number for the states and counties. It's a unique identifier, nominal data, that allows us to uniquely identify these and then bring them together based on that data. So what I can do with what's called a join is I could take this source table and bring it over and append it to the right side of the destination table. So when I open the destination table after the join, I get one big happy table. So you can see here's the FIPS for the original file, and then this is where the new one starts. Well, actually, this one is where the new one starts. Sorry. Let me erase that. Still getting used to these markers. So this is where the table on the left ends, and this is where the table on the right starts. Here, that's where it starts. So now it's one big happy table. So now I can go into GIS and actually, let's say, use this field here to create a map with my symbology. Maybe this population 2002 wasn't found on the data on the left. So this is called joining tables. Now, joining tables are temporary, and that's one of the beauties of doing this, is the fact that you're not messing with the original table whatsoever. All right. So, however, you have to figure out whether or not the tables share a common field, what they call a key. And I'll show an example of that again in a second. But the key to remembering the key, sorry, is that the data in the column has to be the same, not the name of the column. And I'll show you that in a second. Once you find out that you have two columns in each table that have the same data in them, you can join them based on that, and it treats both tables as one big happy single table. The original data is not affected whatsoever. And then you can remove the join at any time, and it's as if you never did it. So that's the beauty of the joins and relates, is that it's temporary. However, it can be very powerful. So let me give you an example. So here is the state of, if you look at the name of this, it's state underscore ABBR, or this one might just be state. Okay, even though they have the same data in them, these are the two-letter acronyms for each state. Because the data in the column is identical, or the same type of data, we can use it as a join. Whereas, even though their names are different, that does not matter. It's what the data says in the table itself. All right. So now there's some conventions that have to be dealt with here when you're doing joins. Now you'll see this up here called one-to-one. We'll talk more about that in a second. This is called the cardinality. Now, when you say this, this means the one, this is the destination, this is the join, or excuse me, the source table. So the destination table is always on the left when you say one-to-one. It's one row in the destination table to one row in the source, which I always found a little weird because the data is actually going from right to left because you're appending the source data onto the destination table. So it's a little weird. It takes a little getting used to. But these are very easy to do within GIS. So if you have basically a 50-50 chance of getting it correct. So a one-to-one join is the easiest one to understand. You have one column here that matches exactly with one column here. So you'll see MT on the right matches exactly with MT on the left. All right. So, or you have Hawaii down here matches exactly with the Hawaii up here. There's only one column, or excuse me, one row that matches which on the right that matches with one row on the left. And that's the easiest one to understand. So it's going to take this column here, or excuse me, this row here, and append it onto the end of the row over here. And so we call that the cardinality. So there's one row in the source table to exactly one row in the destination table. Again, it's read left to right. So this is the table on the left. This is the table on the right, even though the data is technically going right to left. It's the weirdest thing, I know. So there's four types of cardinality. Now, I will mention right out the get-go, we don't deal with this one at all. This one is very complicated and requires enterprise database management systems. And it's very complicated. But the other three are a little easier to deal with. So you have one-to-one, like I just mentioned up here, one-to-one. So there's one row in the destination table to one row in the source. And here's some examples. There's one state to one governor, right? You don't have more than one governor. You have one country to one capital, So again, even though I read it left to right, if I were to do this join, the governors are being appended on to the states. The capitals are being appended to the countries. All right. Then you have what's called many to one. So I have many cities to one state, or many schools to one district. All right. Even though, like I said, the data is going in the other direction. So the states would be appended to the cities, the districts would be appended to the schools. There is sort of an inverse to this called one to many, and we'll talk about that in a second. This is the one to many up here is a little bit different than the two on the left over here. So here you have one state to many cities, which causes a bit of an issue, and we'll explain that in a second. You'll notice that these are sort of inverse of each other. It just depends on how you ask the question. So down here in many to one, we have cities to states, and over here we have states to cities. So it's sort of just the opposite. The reason that is it depends on what data you need back. It depends on um, how you're asking the question. I'm just trying to clean this up a little bit. So this can get kind of tricky at times, but at the same time, it just takes practice like everything else. Again, you have a 50-50 chance of getting it right pretty much. All right, so here's the actual rule of joining. I'm going to read it right off the screen. Each record in the destination table must match one and only one record in the source table. Okay, so if I have one Washington over here, it has to match up exactly with one Washington over here. All right, here's Hawaii down here, one Hawaii down here, one Hawaii down here. Now, even though that's a one-to-one join, many-to-one actually works as well. So here's Washington over here, and this row here is going to be appended to all of these rows that have the Washington over here. Now that creates some redundant data, but it's still important. Okay, so that's okay, we can do that. So this row on the right is going to be appended to each one of the rows on the left. That's a many-to-one join. So those are the kind of easier ones to understand, especially one-to-one. So and you'll use one-to-one quite often, and many-to-one somewhat often, and then you have the other one. So what happens if you have the opposite? Okay, so you have you have many rows over here with the state of Washington, and then only one row over here. There's no possible way you can do this because which one of these rows on the right do you put in there? It becomes ambiguous, and therefore it breaks the rule of joining. It violates the rule of joining because there's more than one row on the right to one row on the left. So that means we have to use what's called a relate. All right. Now, before I get into relates, there's a little thing that you'll see sometimes when you're doing joins, and if there's no match, what you'll get is called a null value. And sometimes this can be a good thing, and sometimes it can be a bad thing. Sometimes it'll tell you whether or not you did it right, and other times if you did it right, you'll still get them because you'll notice that this is Puerto Rico. Okay, these three are Puerto Rico. Now, technically, that's not a state. Okay, it's a territory, although it's included in the states, but it wouldn't be included, let's say, in the counties layer or something like that. Okay, so therefore, you're going to get these null values. You can also do multiple joins, what I call daisy chaining. Now, this could get very confusing, but it can be done. So if I do a join here for the first source, now then those two are now joined. Then I can bring another one in and join it again, and you can daisy chain the joins. However, this is something here. You never join a source table. What do I mean by that? A, a join source table. You have a source table is the table that's being appended. So once you have that appended, you can't join to it again. So these get complicated. I just bring it up just so you know it's a thing. It's not something you're going to want to do a lot, though. It gets very complicated. Okay, so getting back to our example, if what happens when you have more than one row in the source table and only one row in the destination table where it creates an ambiguous situation. You have to use what's called a relate. A relate is where the tables remain separate. Okay, so the tables remain separate, and the items in one table may be highlighted in items selected in one table may be highlighted in a related table. So it's not exactly like a join, but it still works. So let me set this particular screen up. So what they did, this is the U.S. states table over here. And in the states table, they have a field called subregion. That's this right here. So what they did is they highlighted all of the New England states. You'll see all of these are New England that are highlighted here. New England, New England, New England. Okay. So what they want to find is all the representatives that are within the New England states. So you'll see there's 6 New England states. So we should get back some number, whatever that is. Well, that's what we're trying to figure out. Some number of representatives that represent the 6 states in the New England subregion. So this is just a select by attributes here on the left. Okay, so they highlighted these, and now we're going to do something with them. Now, to do something with them, we would run what's called a relate. Because the stuff on the left is highlighted, like I mentioned before, the rule of GIS states once something is highlighted, anything you do to that particular attribute, in this case subregion, is only going to be done on those that are highlighted. So when I run that relate, now all you'll see is over here is I get back all of the states, here they are here, that are highlighted in the main right there. All of the representatives of only the states in the New England subregion, and there happens to be 22 of them. There's no other way to do this. You can't write a query to do this because it would be too complicated. You'd have to do it multiple stages. So this is one of those instances where relate solves the problem, and it solves it fairly quickly. Now, once I have this stuff highlighted on the right here, I can run statistics. Like for example, here's SQMI. I could right click on that, go to statistics, and it would give me the area that all of these representatives represent. So I don't know if that would be important, but you can do that. Okay, so getting back to table statistics, this is a very often used thing it's just something in GIS you do all the time. In my class, when we're doing our geologic exercises at UWM, sometimes you just need a quick and dirty sort of statistic to move on. You might enter it into an Excel spreadsheet or something to go forward with an analysis. Okay, so if I have here's population 2010, okay, and this, you'll notice it says count 6. Okay, so this is probably the 6 in the New England subset, the subregion that we just saw in the previous slide. So here's the statistics: the minimum, the maximum, the mean, and the sum. All right. Now, whatever you need for that, it's not important, but there's the numbers. You can actually click on those, highlight them, copy it, and paste those numbers right into an Excel spreadsheet if you're doing something like that, or maybe into a new field that you're calculating. But this kind of thing is done all the time, and it's super easy. You just right click on the top of the column, go down to statistics, and if you have anything blue highlighted, like I mentioned in the previous slide, anything blue highlighted, those are the only statistics you're going to get. So this is another really awesome way of quickly getting towards that, further that analysis that you might need to whittle down the data, whittle down the numbers to get at just what you need. Another technique you can use, which is called summarizing tables. All right, so this is calculating statistics for groups of features in a table. All right, it's grouped by unique values in the one field, and then you can choose which statistics you need. Do you need the sum of whatever you're looking at? And I'll show you that in a minute. Do you need, the mean, the average? Now, these can be a bit tricky because if you look at that first question, it says how many people live in each subregion. So your first instinct would be, oh, well, I need the population. Well, that's not true. Why is that? Because we want to know which subregion everybody has or which population for each subregion. So in order to do this particular summarize, you actually have to right click on subregion to get to that number. All right, same thing with the other question. What is the total area of each subregion? So you have to look at the question and say, okay, how am I grouping this? And we're not grouping it by population or grouping it by area. We're grouping it by subregion. All right. So then I just right click on the word subregion and I go down to summarize, excuse me, right here. So I right click on subregion, I go to summarize, and then this dialog box pops up on the right. Now it tells me right here which field I right clicked on. Okay, so you want to make sure that's the correct one. Now in this field here will be all of the attributes within your attribute table. And within each attribute, so here's population 2010 here, you have the option of all of these statistics. Now, let me, right off the get-go, only check what you need. If you check all of those, you will get back a boatload of data. So for this, we just want the sum. That's all you need. And then most important, step 3 here, down here, make sure you know where you're saving your table. Now, hear what I said there. Table. The output of the summarize field is a table. Okay. So you have to know exactly where you're going to store that thing. All right. Store it in a geodatabase or in a folder, wherever you need it. But make sure you only check, in this case here, sum. You don't want to check everything, just what you need. So the output for this particular, the summarize thing is a table like I mentioned. Now here you'll see, here's the field that we're grouping everything on. That's the subregion. So there's 9 unique subregions. Over here on the far right, we have the sum, which is the checkbox we check, of the population for each one of the subregions. That's what we wanted. However, you also automatically get what's called a count field. And this is really handy. If I went back to the last slide, you notice we checked the sum field. Sometimes you don't care about the statistics, you only care about the count field. Now, if you look at this count field, what do these numbers represent? These numbers represent the number of states within each subregion. So the East, North, Central has 5 states. All right, the Mountain region has I think that's 8. I just wrote over my line here. So each subregion has a specific number of states associated with it. Yep, 8. So sometimes the count field is all you need, but if you need statistics, you just click the checkbox you need as well. You're going to get back the count field no matter what. So now that we have this table, what do we do with it? Well, there are no, you'll notice there's no points, lines, or polygons. This is a standalone table. However, within this table, there is a field that is identical to the one that we created this table from, and that has the subregion field in it as well. Okay, so therefore we could take this output table, and you guessed it. So once we have the output for the summarized table, we can join it back up based on the subregion field, which is also in our states layer. Now, because of the fact that this has no points, lines, or polygons, you cannot start a join with the source table. You cannot initiate a join that way. When I say initiate, I mean right click. In GIS, and I'll show you this in a bit, in GIS you start a join by right clicking on the destination table, in this case, which is the states table. You never ever right click on a standalone table like this that has no points, lines, or polygons to start a join. So this is a standalone table. It has no geometry associated with it. So you never right click on this over here on the right. So once we have that, then we can join these up, and then we can use the sum of population 2010, which is way over here on my table that I created, and create a map from that. So this map would not be able to be possible without doing a summary statistics first. So now we have the sum of all of the various subregions mapped according to their population, which is very handy. Okay, so we're going to talk briefly about some database storage concepts because there's a few rules you have to follow in order to make GIS work for you. So fields or columns have to have specific types available. Okay, so this is where it differs from something like Excel. In Excel, you can just start typing either letters or words or numbers. Um, in GIS, it's a bit different because it's an actual database. You have to actually define the column, the field, um, with what kind of data is going to go in there before you ever put any data in it. And not only that, once you define it, you can't change it. So if you, let's say I need something that's going to hold numbers and I accidentally put in text, I have to delete the column and redo it. Not a big deal, but in GIS, it's very, very strict about that. You can't put text in a number field and you can't put numbers in a text field in order to do math. And I'll show you that. So there are some naming rules. You want to keep your column names, your field names short, no more than 13 characters. Use only letters and numbers, and it has to start with a letter. Keep them short, keep them sweet, but keep them as descriptive as possible when you're creating new columns. So without going into gory details about all this, here are the various field types that you're going to see in GIS. You have short, which is anything from 255 to you'll see the examples. I'm not going to go into huge detail on this. For most things, you're going to use, if you have really short numbers, let's say an address, those are small numbers. An address field, you can use short. For most things, I use either flat, float, or double. It really doesn't matter. Um, a lot of this was set up many, many years ago based on the computing power at the time. So if you make all of your columns double or float, you're not going to notice anything different. Now, if you need really, really super huge numbers, like something like this, then yes, by all means, make sure you're using double. But, um, and then obviously for text, you're going to need the text field. Date formats are kind of a pain in the butt, but you can also use them. And then what are called blob features, which we're not going to use, but that's where you can store things like images and stuff in a geodatabase. So here's some examples. So what would you use for your last name? Well, that's text. So you would obviously use text, right? All right. So number of children in a household. Well, let's hope that people aren't having exponential amounts of children, so you probably use short. Student's grade point average, well, that can go out a few decimal points. So, maybe float. Oh, okay, year of birth, that would probably be long. And county population, that would either be float or double. I mean, you could use either. It would actually be float or long. So, I mean, that for county population, you'd probably actually use long. But again, a lot of this was set up many years ago with computers that didn't have a lot of computing power. You won't notice the difference too much anymore. But, you want to try to use the correct field for the correct type of data. All right, so there's lots of different formats for data in ArcGIS. However, they're all going to look like the screen you see in front of you. Even if you bring in an Excel spreadsheet, it's still going to look like this. All right, so you can use what are called DBase files, which is what you've been using all along. That's sort of the standard format for ArcGIS. There's an old format called info files, which no one ever uses anymore. You have ASCII text files, which are tab or comma delimited. I use these personally because any earthquake data and things like that, those type of data that I bring into GIS, those are found in those. You might have heard of a CSV file. That's a comma separated file. You can bring in records from database systems from previous SQL queries. And then finally, everybody's favorite, Excel worksheets. Now, Excel works a lot differently in GIS than it does in Excel. So there's a lot, it's not as cool as it sounds. So we've seen this before um, several times. You have the title when you're working within the confines of GIS. You have the column name. You know, if you right click, you get this, all of these options here, things like sorting, the number of records, the status bar. The status bar here tells you if how many you have selected out of a given amount. So here's the states. So if I have all the states with the letter M, I always forget how many there are. I think there's like 8. This would say 8 out of 51. So you've all seen this before. Um, and then you can also manage multiple tables. In the old versions, prior to version 10 of ArcGIS, when you open tables, they open separately, and now they open as tabs. Down like you see down here in the corner, they open as tabs. However, you can still create these vertical displays like this where you have them side by side, which is kind of nice once in a while. And it's easy to do. Just create a new vertical tab group. It's not a big deal. But again, this is all personal preference. To me, it takes longer to make a vertical tab. I can usually see what I need fairly quickly. The table options menu, which is this button right here, shows all of this stuff. And you can do quite a bit from there. You could turn fields on. You could do select by attributes, switching, selection, select all, adding a field. This is where you add a column to your data. Um, and then you would do a field calculator, which we'll talk about in a bit. Here's where you do joins, and you can do joins and relates here. Okay. Again, to do a join and relate, to go back to that, you right click or you initiate this join or relate from the destination table. So the one you would picture on your left. And then you can do some other things like graphs and things like that. You can adjust the field width. You've already seen this before. You can make the columns wider or narrower depending on your needs. Sometimes I make the shape feel really narrow so I can see things better because you can't get rid of that field. So, but I know they're polygons, so I don't necessarily need to see that. So it's just a matter of personal preference and how much real estate you have on your screen. In the Fields Property tab, if you go to right-click Properties, you can turn on and off fields. I highly do not recommend this. I never turn fields off. One of the reasons is depending on how often you use the data, chances are you're going to forget that you turned it off. I remember many years ago searching everywhere for this data. I knew I had it. And then all of a sudden the light bulb finally went on after like searching for like a week or something like that, thinking I lost data. Turns out I had just turned the columns off in that particular data attribute table. And I felt really stupid and never ever touch those anymore. Just don't do it. It's not worth it. I only do that now for one specific thing, and that's with soil data or climate data. Because when you download climate data, you get back way more than you need, whether you like it or not. And so, yes, I do turn off a lot of them in climate data. You can you can right click the field name and get some quick information about it. Now, when you're dealing with numbers, we're all human, and sometimes reading numbers can be hard to read, especially on a computer screen. So you can go into the properties and change, like for example, the number of decimal places, the number of significant digits. You can show the thousand separators, which is really handy. You'd be surprised, especially as you get older. It's really hard to read these kind of numbers on this here. However, once you put the commas in over here, it makes life much easier. It just does, especially with this, like especially in this range. Is that 66,000 or is it 662,000? The thousand separators, one tiny little checkbox that makes just seeing things on a screen way easier. It's one of those little tricks of the trade, so to speak. And then obviously you can also add if you're dealing with currency, you can add the dollar sign as well, which makes things easier to read as well. Sorting, such a simple concept, but it's so used all the time. So if I do a query, or even if I don't do a query, if I open a table and I want to know which state has the highest population or which state has the lowest population, I don't need to run a query for that. I just right click on population and sort them. Or if I want to put all of my states in alphabetical order. So you'll notice object 1 here is Hawaii, object 2 is Washington. So they're obviously not in alphabetical order, but being human, we kind of have a tendency to want to see things that way. So I can assort them either from A to Z or Z to A. With a right click, sort ascending will give me A to Z, sort descending will give me Z to A. Same thing with numbers. High to low, or ascending is low to high, and then descending is high to low. So it all depends on what you need. If you need the most of something or the least of something. It's a simple little thing that you use constantly in GIS. So we already talked about select by attributes. Again, just a real quick refresher. Double click this stuff. Do not type in here if you don't have to. Accept numbers, actual numbers like 1,000,000, 500,000, whatever. Use these, double click on this, click one of these buttons in here. If you have to, you might need to get unique values to populate all of possible values. Then you double click on something in there. So just don't type in anything down on the bottom like that. You know, that's something that a lot of new users do. So you don't want to type down in here at all if you don't have to. So once I have that light blue color on my screen, you'll see here's all that light blue color here. And then you'll see it again in here in the attribute table. Once I have that, you can see here, it tells me I have 34 out of 51 selected. On the table here, though, you'll see you have both the blue and the white still visible. Well, as an added little bonus, so to speak, from a visual standpoint, you can just mask out all of the non-selected values by clicking this button here. And then it'll only show you those values that are selected. This is just a visual thing. You're not deleting anything. But the beauty of this is now I can visually see, okay, here's exactly what I selected. And let's say I want to do some type of statistic thing. I can right click on this and do statistics and get the min max population, or excuse me, the population if I do it over here. So the weird thing about this button though is that if I don't have anything selected over on the excuse me, if I don't have anything selected and I click this button here, this will be blank. It won't show anything, and that's freaks a lot of students out at first. They say, "Oh, where did all my data go?" And that's because they have this button here selected, and they should have the other button selected. Oops, sorry. So normally this one over here on the left, that's the default button that's selected at first. You don't have to use this button on the right. It's not required, but it does come in handy from a visual standpoint to just see exactly what's selected. Now, a huge part of doing selections is knowing when to clear them. Going back to that rule of GIS, if you have something selected on your screen, any tool you run, any statistics you run, any summary statistics you run will only be run on what's selected in blue on your screen. Period. End of story. So if you're done with your selection, you by all means must clear it before moving on. I've forgotten to do this. I'm sure everybody who's done GIS has forgotten to do this. And that little white button right here, and there's a bunch of different places to do it. Here's the one on the selection tab. Here's the selection tab at the top of the program. There's a whole bunch of different places to do this in order to clear selections. I think we already mentioned this. I am going to skip this slide. So in order to add a field, you have to first know what kind of data you're in there. That's why this previous slide was on there. So if I go to into the table options and I go to add field, I have to explicitly tell it what kind of data I'm going to put in there before I ever put any data in there. So you have to know ahead of time what you're going to do. So right now I have it set to text. That drop down menu will give me the same options that you saw in that green slide in the previous slide. It'll be long, short, float, double. It'll be one of those. If I know I need text, I set it to text. I could set the length here. If I know I'm going to have addresses, addresses can be pretty long. Even last names can get kind of long. So you might want to set that a little higher just to make sure that nothing gets truncated. So another option that you have when you're adding fields is if you know you're going to need several at a time, you could do it within the um, catalog properties. So if you go to the fields tab within properties, you can add multiple fields and tell it which kind of data is going to go in each field right away. I typically don't do this because I usually do one at a time, but you have that option if you need to add more than one at a time. So just like Excel, you can actually calculate fields. Sometimes you want to generate your own data. It happens, and there's nothing wrong with that. So this is where GIS is similar, not exactly the same, but similar to Excel. So what you can do is you can either calculate a field or you can actually edit within a field. Now we haven't done editing up to this point in this course, so you have to actually open the editing toolbar, add it to your map, and then you have to go to start editing. Once you start editing, you have to be extremely careful. You now have complete control over your data. Up until this point, we've never typed within an attribute table. Now you can actually type the values in there if you need to. Now, you're only going to do this probably for um, uh, small amounts of data. You're not going to want to type in, let's say, low or high for thousands of rows of data. There's other ways to do that. That would probably be better. But if you have 10, 15, it'd probably be quicker to just type them in. Once you're all done with that, then you save your edits, and now stop editing, and now it's part of your attribute table. So you can do this manually. That usually doesn't happen very often though. A better option is to calculate a field. It's very similar to entering a formula in Excel. So once I know what kind of data I need, I'm going to make a new column. It's going to be called percent Hispanic, percent Hispanic, and here PERC underscore HISP. And we know already it's going to be a decimal point type number, so we're going to give it a float. Once I do that, I click OK. That's horrible. And then I get a new column that's completely empty called percent Hispanic. Once I have that, now I right click on here and I'm going to do what's called a field calculator. Okay, the field calculator is similar to a query. So now that we have a blank column here, we can go to the field calculator again, like I mentioned, and it opens up a new dialog box. Now this dialog box is very similar to a select by attributes, okay? And once you run the calculation, it can't be undone, although you can overwrite it, all right? So just like in the select by attributes, you don't want to type anything in this box if you don't have to. You want to use the buttons and double click as much as available. Now, like in Excel, you're creating a formula. However, what's different is in Excel, all formulas begin with an equal sign. You'll notice here, this one is provided for you. So you don't have to put the equal sign in here at all. All right, it's already provided for you. And now the thing you want to remember is use double clicks and the buttons available to create this. So I scroll down here to I see Hispanic and I double click and it brings it in here. Here's the divide button and that puts that right there. Here's the population 2000. I double click that and it brings it down here. Here's the multiplication button. It puts it right there. And then yes, I do have to type in the 100. So it's taking row by row the Hispanic population, dividing it by the total population, and multiplying it by 100 to give us a percentage. So it's very similar to Excel. I'm creating a formula and it does it row by row. There's also all types of math functions that you can use. Um, there's some logic that's built into this. We're not going to go into that. But the idea being that you can actually do these and you can also save them as well. You could save um, these particular formulas and do all kinds of things with them. If these get really complicated, you don't want to have to keep retyping them. You can save them and then reload them later. You can also do geometry measures. Now, one of the benefits of using a geodatabase, one of the major benefits, is that the shape underscore area and shape underscore length are automatically calculated for you. Now, you're not going to get area if you're using points or lines, but here's the shape underscore length and here's the shape underscore area. They're usually on the far right side of your attribute table. Those are automatically calculated for you, and the units are the same as the coordinate system. So they're either going to be square feet or square meters. So let's say I need some other geometry field. I need acres, or I need hectares, or I need square kilometers. Well, that's really easy to do in ArcGIS using a few other options. Now, shape files, the older file format that you still see around, do not create areas and lengths automatically. And it's vitally important that you understand this. So if you're doing calculations that require lengths or areas, which is all the time in my world, you'll see older files that have, let's say, the area field, the perimeter field, or those are not necessarily accurate. Those were probably created way back when they were actually what are called coverages, and they've been just sort of handed down through the iterations of the newer file formats. Well, now we have geodatabases, which are the most accurate forms of this, so you don't want to use any of these for anything. Those are old, antiquated, and you just don't use them. So the reason why that's important is if you do things like there's a tool called a dissolve. You'll see all these little, there's a piece here, all these little pieces that make up this polygon. Well, if I do a dissolve, it makes one big polygon. Okay. If I do that in a shape file, none of the areas are going to be updated. However, if I do this in a geodatabase, they will. That's why, I tell my students and then require them to use a geodatabase for any and all data for their projects for that very reason. Because at some point you're going to need an area or a length to understand what's going on. So you can quickly do this. I'm not going to spend a lot of time on this. You right click, you go to calculate geometry, and then you have the option of what you want to do, area, and then what are the units. In this case, it's acres. So it's pretty quick, it's pretty easy. Now, real quick, let's go through how to actually join tables in ArcGIS. And I mentioned before, it's really easy, and you have a 50-50 chance of getting it correct. So if I take this, if I'm going to do a join, I have to first understand what the cardinality is of that join. So once I know what the cardinality is, I have to know what the destination table is. In ArcGIS, you always right-click the destination table. Always, always, always. So I right-click, I go down to join and relates, all right, and then the join data dialog box pops up. Now, if you read this, it's actually pretty easy to understand. What do you want to do with this later? Well, I want to join an attribute table. Great. So which field in the table that I'm joining do you want to use? Well, I want to use subregion. Okay, that's awesome. So subregion is in my table. Now, what's the source table? What data is being appended on to my destination table? Well, that one's called subregion pop. That's the data. That's a standalone table. There's no points, lines, or polygons in that. And it just so happens to have the same name of the field as up here. So these have to match not by name, although these do match by name. They don't have to match by name. They have to match by what data is in them. These two have to match. Okay. And then I just always keep all records. You don't need to change that. So once I click the OK button to do this, um, the join will take place, and then you open up the original table and go back in it. So these two have to match in terms of the data. Now the beauty is once I put the table in here, the program usually gets this correct and will autofill for you, which is really nice. You can also import tables. Okay, and I mentioned this before. Things like tab or comma delimited. This is earthquake data here, this kind of stuff. And I use that kind of stuff all the time. You may not use it for your needs. You may never have to do this, but just know that it's an option. It's not hard to do either. Excel spreadsheets can also be brought into GIS. However, they're a little bit tricky. Um, and you can't edit them. See, that's a big thing. You're not going to be able to use them like Excel in GIS. They come in as basically standalone tables. So what I typically do is I bring in an Excel spreadsheet and then I just export it to a GIS database or feature class. Now, you have to do some pre-processing to get Excel to work within GIS. So just like in GIS, you have to have that first row that contains the headings. You want to eliminate blank rows, okay? Now, this here it says formulas. That's not entirely true. I'm not quite sure why. That might have been an old requirement. That's really not the case anymore. I've never had trouble with that before. Your formulas won't come into GIS, but the data created by formulas will. So each column should contain only text or numbers. Now, here's the big thing is this one here. Before you ever bring in Excel into GIS, you should go into Excel and explicitly define what each column type is. In Excel, they have a format called general, which is typically what's used. So if I have text, it'll call it general. If I have numbers, it'll call it general. And you can run into issues where your data may not import correctly. So what I do before I ever bring an Excel spreadsheet into GIS is I go column by column and explicitly define each one like you would in GIS, each column in my Excel spreadsheet. So if I'm looking at state names, I right click on it in Excel, I go down, I define it as text. If I have population, I define it as numbers and give it the number of significant digits. Okay, so that it's a necessary evil if you want Excel to play with GIS. It's just to make life easier to make sure before you bring in an Excel spreadsheet that you're formatting all your columns ahead of time. And then finally, if you're going to bring Excel into ArcGIS, you're required to close Excel out. You cannot have them both open at the same time. You will get lock issues. So, just make sure that you have all your ducks in a row with all your formatting, everything ready to go in Excel. Close Excel, then bring it into GIS. So, for example, I find this funny. There's actually a space in this name. You probably don't want that space. You should put an underscore there. But so the first row here has all the column names. This is all text. This in different numbers. So this is a valid Excel spreadsheet that you could bring in. Now there's a little bit more to it than that, but that is a spreadsheet that you could bring into it. You might want to explicitly name your sheets in a GIS to help bring them into, you want to explicitly name them in Excel and then bring them into GIS. Otherwise you have sheet 1, sheet 2, kind of generic. When you bring in Excel into GIS, you only bring in one worksheet at a time. Okay, so you have to tell it which sheet you want. So by renaming them, it just makes it a little easier to know which one you need. So when I want to bring an Excel spreadsheet into ArcGIS, I click on the Add Data button just like I normally would, and I have to choose which Excel spreadsheet I want. In this case, I'm going to do um, the Oregon stations here. So if I double click on that, it goes down to here, and you'll see the dollar sign that I just covered up with the red here. You'll see that dollar sign. That dollar sign represents the sheet there. If you don't explicitly name your sheets, it comes out like this: sheet 1, sheet 2, sheet 3. Although I don't know if it does that with the newer versions of Excel anymore. Automatically gives you 3, but it will say sheet 1. So if you don't explicitly name your sheets, that's what you'll see. And then you double click on sheet 1 to go forward. So once I have the table in ArcGIS, ArcGIS doesn't know what to do with it. There's no coordinate system, there's no points, lines, or polygons. You have to tell the program where on Earth these particular earthquakes or weather stations, excuse me, are. So in this case, you use the Latin lon. Now, in order to do this, you have to have numbers like this. These are called decimal degrees. That's not important, really that big of a deal. I'm just explaining you can't use all of these over here on the left. This won't get those on your map. Only these two will. They have to be in decimal degrees. So once you have the decimal degrees, you could tell the program where they are, and then eventually you can it'll show up on a map, and then you have to, it's a bit of a process. You have to define a projection and then project them to get them to show up correctly where you need them. And you do that by, when I have this is the Excel spreadsheet, I right click, I go to display XY data. Then when that opens, their X value is always your longitude, your Y value is your latitude, okay? And then you have to give it a projection. I do this slightly different. I actually I just bring this in without any projection. I use the define projection tool to give it, let's say NAD 83 or NAD 27 or WGS 84. Then I use the project tool. So I make it a bit long of a process, but I know I'm going to do it correctly by this way. I really do not like using this at all. And then once you have that, you'll have what are called events on your screen. You'll see the word events there. All that means is it's a temporary file. Yes, they're on your map, but they're temporary. They're stored in a weird place on your computer. So then you just right click and you export them to a feature class in a geodatabase or a shapefile. And then you export them, and then they're permanent. Now you have them forever. They're already projected and you're good to go.